Hello to all my viewers. This is Dr. Dhaval Maheta, and today we'll understand few-shot prompting in large language models. Few-shot prompting is another strategy utilized in machine learning, where the model is given multiple task-specific examples before presenting the actual prompt. Unlike zero-shot and one-shot prompting, this method provides several samples or shots that act as references for the model on the expected structure or context of the response. The idea is to enable the model to generalize better over the task from these few examples. The demonstrations serve as conditioning for subsequent examples where we would like the model to generate a response. According to Towering, few sort properties first appeared when the models were scaled to a sufficient size. The model is trained with a small number of examples or training data points for a particular task, typically ranging from few to several examples. Let's try to understand few short prompting by this figure. In this figure, you can see that we provide many images of cats and dogs for training purpose to the LLM models, that is large language models. After training is over, we provide fresh images. So this query set is a fresh images as testing data to the model. The objective of the model is to identify is it a dog or a cat. So basically, it is used for the classification purpose. Now, what are the advantages of few-shot prompting? Few-shot prompting allows the model to leverage pre-trained knowledge efficiently. Instead of requiring large amounts of task-specific data for fine-tuning, few-shot prompting only needs a small number of examples, making it more data efficient. Few-shot prompting enables models to quickly adapt to new tasks or domains with a minimal additional training. This flexibility is valuable in scenarios where tasks change frequently or where new tasks emerge regularly. Because of few-shot prompting, because few-shot prompting requires only few labeled examples, it can be applied in situations where obtaining large amount of labeled data is impractical or costly. This makes it accessible to a wider range of applications and domains. Researchers and developers can quickly prototype and experiment with various tasks and prompts using the few-shot prompting. This rapid iteration cycle accelerates the development of new applications and models. Few-shot prompting facilitates transfer learning by allowing models to transfer knowledge from one task or domain to another with the minimal additional training. This transfer of knowledge can improve performance on related tasks and reduce the need for task-specific training data. By providing explicit examples in the prompt, few-shot prompting offers increased interpretability compared to the traditional fine-tuning approaches. Users can understand how the model arrived at its prediction by examining the provided examples and the generated output. Limitations. Few-shot prompting might not perform optimally in highly specialized or niche domains where the predetermined model lacks sufficient context or knowledge. While few-shot prompting requires less label data compared to traditional fine-tuning, it still necessitates some label examples. In cases where label data is scarce or expensive to obtain, few-shot prompting may not be feasible. The ability of the model to generalize from a few examples to new, unseen examples can be limited. The model might struggle to handle variations or nuances that were not adequately covered in the few short examples. Few short prompting relies heavily on the provided prompts, which could introduce biases or reinforce existing biases in the model's response. Careful crafting of prompt is necessary to mitigate these biases. While, while few-shot prompting is effective for certain tasks, it may not be suitable for tasks requiring complex reasoning or multi-step inferences. The model's ability to understand and execute complex instructions might be limited by the few-shot nature of the training examples. The context provided in the few-shot prompting may not always be sufficient for the model to generate accurate or relevant responses, especially for longer or more context-dependent tasks. Let's take the example. Generate a movie review for the film Inception, similar to the following examples. I loved Inception. The plot twist kept me on the edge of my seat throughout the movie. While Inception had stunning visual effects, I found the plot overly convoluted. So these are the examples, and we will copy this prompt. Enter. So as we had provided the examples, so it has given me the movie review based on these examples only. Okay, let's take the another example. A watapu is a small furry animal native to Tanzania. An example of sentence that uses word watapu is we are traveling in Africa and we saw this very cute watapu. Now we give the another word. To do a fardoodle means to jump up and down really fast. Now giving me the example on this particular word. I'll copy it. Enter. So you can see here it has provided me the example of fardoodle. The children were so excited about the surprise they began fardoodle in the living room. Now let us take the another example. In this website, we are having the skills required for the software developer. And in the another website also, we are having the same. Now I want to generate the advertisement. I want to publish the advertisement for the recruitment of software developers. So let us copy this link. One, copy. I'll write here the prompt as create an advertisement for the post of software developer based on this given URLs. That is the link. So Control V and I'll copy this also. Enter. So you are getting two responses. Depending upon your requirement, you can choose the advertisement. So this one gives me the required skills and qualifications, preferred skills. And this gives me responsibilities. Responsibilities are here also, required skills, preferred qualification, what we offer. Okay, let's proceed further. What is the difference between zero shot, one shot, and few shot prompting? Learning type, zero type. The model performs tasks without prior specific examples. Now the example prompt is classify this review. I love this movie and the sentiment. So we want to detect the sentiment in it. The output is sentiment is positive. One shot. The model learns from a single example. Classify this review. I love this movie. Sentiment is positive. Classify this review. I don't like this chair. Sentiment. So one example has been provided. The sentiment is negative. Few shot. The model learns from a few examples. Classify this review. I love this movie. Sentiment is positive. Classify this review. I don't like this chair. Sentiment is negative. Classify this review. Who would use this product? Sentiment. So sentiment is positive, negative, or it can be neutral. Now let's see some difference in all of them. Number of examples. No label examples for target classes. Only one label example per class. A small number of label examples per class. Training approach. Models are trained to generalize to unseen classes without any label examples. Models are trained using a single example per class and learn to generalize from it. Models are trained on a small number of examples per class, allowing for more robust generalization. Generalizes to completely new classes not seen during the training. Limited generalization to new classes due to the single example per class. Generalizes to new classes task with improved performance compared to one-shot learning. Challenges. Capturing semantic relationships between classes without explicit examples. Limited data may result in overfitting or poor generalization. Balancing between exploiting available data and generalizing across tasks. Challenges in learning robust representations with limited data. Applications. Tasks where no labeled examples are available for target class, such as zero-shot object recognition. Tasks where only single example is available per class, such as rare object recognition or identification. Tasks where label data is scarce or costly to obtain, such as medical diagnosis, few-shot classification, or language modeling. Examples are recognizing novel objects without any prior examples during training, identifying new species of bird from a single image, classifying sentiment in customer reviews with only few labeled examples per sentiment category. Applications of few-shot prompting are character recognition, visual navigation, image classification, object recognition, video classification, text data, audio processing, and translation. So this was all about few-shot prompting. For more such videos on prompt engineering, kindly subscribe to my channel. You can also refer my playlist in which I have uploaded videos on data science, machine learning, and artificial intelligence. Please don't forget to like and share my videos and subscribe my channel. You can also follow me on different social medias, link given in the description box.